Welcome everybody to this session of statistics for the topic of hypothesis testing, step 5. Take a sample and arrive at a decision. Before we continue, let's remind ourselves what is a hypothesis and hypothesis testing. A hypothesis is a statement about the value of a population parameter, population mean, or population standard deviation developed for the purpose of testing. Hypothesis testing is a procedure based on simple evidence and probability theory to determine whether the hypothesis is a reasonable statement or not. In this one session, we will see what the step 5 out of the 6 steps of hypothesis testing is, which is take a sample and arrive at a decision. So now, from step 3, as part of step 3, we select the appropriate test statistic, whether we're going to use the Z or the T distribution. Now, how do we know which one to select? Well, the main question is, do you have the standard deviation of your population, sigma? And if the answer is yes, then you use the Z table and you know that you will calculate the test statistics using this one formula for Z. Now, if you do not have the standard deviation for the population, that means you have the standard deviation of a sample, then you know that you will use T. And this is the formula that you would use for test statistics. Okay, so this is from step 3, you need to know which distribution are you using. Are you using Z or are you using T? Now, that is very important for step 5, in which we take a sample and we arrive at a decision. So now, how do we do that? Well, as part of the exercises, or if you're working on a project and you need to take a sample to test your hypothesis, then this is the steps where you will take a sample from the population. Second, you will calculate the test statistics. Now, from step 3, you already would have decided if you were using the T or the Z value. Accordingly, with your sample, you will calculate either Z or T, and you will have the mean of your sample for either of the two formulas minus the mean of the population for the two formulas divided by sigma if you have the standard deviation of the population, or S if you have the simple standard deviation of for your sample, the simple standard deviation instead of the population standard deviation, which is sigma, divided by, for both formulas, the square root of your sample size, that's your N. So as you can see here, both formulas are very close to one another. The only difference is, are you having the standard deviation of a population, which is sigma, or are you having the standard deviation of your sample, which is your S? Think about S for sample, and sigma is population. All right, so now, once you calculate your test statistic, which out of the 6 steps that we have, only step 5 is when you do the math. Then you compare this test statistics, your math, to the critical value. And the critical value is a line that separates your reject from do not reject zone. This is what you do in step 4. Once you compare them, if the test statistic is in the region of rejection from your step 4, then you reject the null hypothesis. And once you reject or not reject is when you arrive to a decision. Now, this is what we saw from step 4. For example, just call this case 1, where you have a critical value, and then you do a test. The critical value is negative 1.64 for this particular figure. Let's just assume that your test statistic, you got a Z equals to 0.5. Well, 0.5, this line here is negative 1.6. The line Z in the middle is always 0. So where is 0.5? 0.5 will be a positive number. So it will be a line that will be more than 0. Let's just put it here. So if your Z, your test statistic is positive number, then you know that you are in this region, which is then you do not reject the H0. Let's assume we are on the second drawing here, and the critical value here are negative 1.96 and positive 1.96. So let's assume that we do our test statistic and the Z is equal to negative 2. All right. So what is in the middle is always 0, ladies and gentlemen, always. Z in the middle is always 0. So you get your sample, you calculate your test statistic, and you get a negative 2. Where is negative 2? Well, negative 2 is more negative than 1.96. So you're somewhere over here, which means that you're rejecting H0. So H0 is rejected. In the one before, you did not reject it, so you accepted it. And let's assume you're on the third drawing here, and you do your test statistics, and the Z that you get is equal to 1.5. Okay, so your critical value for this one exercise here is 1.64. And always in the middle is 0. So where is this 1.5? Well, 1.5 is less than 1.64, so it's somewhere over here, which means that you're on your do not reject zone. So once you figure out where the test statistics lands, are you in your reject or you not reject zone, then you will look at the last step, which is interpret. What does it mean whether you're rejecting or not rejecting? At that point, you will go to your step 1 and figure out what it means. If you're canceling, if you're rejecting H0, then you're accepting H1. What does your H1 say? If you're rejecting H1 and you're accepting H0, that's fine too. Then you go back to your step 1 and you figure out what it is that H0 is saying. Either way, then you put in a normal full sentence, what does it mean for your exercise, whether you're rejecting or not rejecting your hypothesis testing. Thank you so much. Hope this helps. And have a wonderful day. Bye.